Alrighty. Well, others who are joining a little bit later than this, they can catch the middle of the webinar, but we're going to begin. So, hello everybody. Welcome to another Green Energy Series webinar. Today we're going to be talking about cottage clusters and how cottage clusters can offer economies of scale that can reduce the cost of construction to enable more energy efficient features to be incorporated while still keeping homes affordable. We're going to be looking at different case studies of how this played out. So before we dive into the topic, a little bit about Solar Oregon. Solar Oregon is a nonprofit founded way back in 1979 when solar photovoltaics were just beginning to gain some adoption. So Solar Oregon from 1979 grew from grassroots efforts to support clean and renewable energy, and we're continuing that mission through today. And we do that through a number of different ways. We do a lot of education, outreach, and community advocacy. We routinely host How to Go Solar Plus Storage webinars. That's kind of like our 101 slide deck. And we continue to reach new people who are just learning about solar and storage through this webinar. Every year, we do a number of solar tours. Two of our key events every year is a solar winery, where we look at all the great wineries in the Oregon area that have also adopted solar. Turns out that solar and growing grapes for wines goes really well together. Um, a lot of agricultural crops actually grow better when under partial shade conditions. And the water reduction is also a great factor. And a lot of farmers are saying that they get better and higher quality yields growing under partial shade conditions. Additionally, they get all the electricity generated from those solar panels to help offset, all the processing equipment, refrigeration that's needed to produce products like wines. We also have another great annual event, which is the Go Zero Tour, where we tour a handful of homes in both the Portland and then also have videos of homes throughout the rest of Oregon that have gone net zero. And the tour allows people to really understand how the different owners of these homes have done it and hear their stories. Most people in existing homes do this over the course of 5, 10, or more years. It's quite a journey to be able to electrify component by component of different homes as funds allow. So it's wonderful to, hear how, mere mortals like everyday folks on a pretty tight budget manages to do such things by sequencing the events over time. We also do solarized campaigns, and these are campaigns where we help coordinate whole neighborhoods to get solar quotes at the same time. And so then the price on those quotes represents the price of a system if installed around the same time as their neighbors. And so this offers the solar contractors participating the ability to offer their customers economies of scale, a concept that we're going to get into more in this webinar also. And then we also do peer-to-peer education events. Those can be either in person or via webinars such as this one, where you can join for free and ask our speakers questions and they'll answer it live. So today, the kind of the flow of this webinar, we're going to do some introductions, introduce the speakers, and then we're going to talk about a case study called the Milwaukee Courtyard Housing Project. And we're going to dive a little bit into the energy design and then have opportunity for you all to ask the speakers questions. So today in this webinar, I'm just the host. My name is Edward Louie. I'm a volunteer and board member of Solar Oregon. During my day job, I work as a building energy efficiency research engineer at Pacific Northwest National Laboratory. What a mouthful. You can find me on LinkedIn. I post quite a bit on LinkedIn. And I'm also have a off-grid, zero energy, tiny house that I built from the just a flatbed trailer, and now I'm just finishing the inside. One of our speakers today is Denise Roy. She's an instructor and architect at Portland Community College. You can also find her on LinkedIn. Denise, do you want to say a few words about yourself beyond that?
Yes, I'm a semi-retired architect, but I have been volunteering with Solar Oregon for several years now. I continue to really enjoy teaching architecture at PCC. One of our classes at PCC, we actually highlighted cottage cluster design. Um, and other than that, I love doing urban sketchers, which is an outdoor sketching painting class with other architect friends.
Wonderful. Look forward to what you have to tell us in this webinar. We'll also have another speaker, Vince McLennan. Is that how you pronounce your name? Vince is president of Enter Design. Vince, can you say a few things about yourself beyond that? Oh, you're muted, Vince.
There we go.
Perfect.
Hello. I've been in the solar industry for about 45 years now. Starting in 1982, I got to install some of the first commercially available solar panels in the US. And I've gone on and owned 3 different companies in 3 states. I currently own Energy Design out of Eugene, Oregon. And I did the original design for the Milwaukee cluster housing project, which was it's an interesting project, and we'll get more into the design aspects of that kind of a system later. Thank you.
Alrighty. Well, Denise, I'll drive your slides. Take it away.
Okay, thank you. Thanks everyone for joining us. We'll start with talking a little bit about cottage cluster housing, which typically consists of a single family or duplex units built closely together, ideally clustered around a common space. And the advantages of this include the fact that they're typically located within existing neighborhoods. So you might have an oversized lot or a couple lots, maybe a house is demoed, but you have the existing neighborhood with this existing infrastructure like schools, parks, and most importantly, transit. The shared common space is great too because it provides some opportunities for social interactions. So the little images we have here, the top one is one that Ross Chapin, an architect and pocket neighborhood developer in Washington, did. The bottom one is a new one, Short Stack Milwaukee. Next. So here we have a site plan on the left, and this is the actual sort of mock-up of 2 actual sites in Milwaukee. We call them the 36th Avenue site and the Harvey Street site. And these sites are available potentially to actually build on. So a detailed site plan has been developed on 36th Avenue as, again, that sort of study of how to excuse me, how to site these units so that they take advantage of some shared infrastructure and also meet the zoning codes. So the drivers of the project include an affordable housing shortage that's been prevalent in Milwaukee for many years, for actually decades, just like Portland and other surrounding areas. Milwaukee changed their zoning code in 2022 to allow cottage clusters. And backing up a couple years in 2017, the MPP, as we call them, mass plywood panels, were first developed by Frez Engineering and Wood Products. They're located in Lyons, Oregon, which is a small town kind of at the foothills of Cascade, east of Salem. Perez studied, their production and design team studied European products and MPP with the assistance of Oregon State University. So again, the site plan here just represents the location and density of a potential, if these units that are studied were actually built. Next. So a comparison, if you will, of cottage clusters. This is sort of an evolving discussion that's going on because many Milwaukee and Portland and other areas have changed their zoning code to allow what people have referred to for quite a while as middle housing. So the cottage clusters are developed with varying designs and varying price points. So I use this as sort of a study. This is what's happening in Portland, or two examples of what's happening in the Portland area. What's noteworthy is that these are both located in well-established neighborhoods. The top one is the Multnomah Village cluster, which is the larger of the two, 17 units. Price point is $455,000. For many people, that still sounds like a lot. However, the median house price in Multnomah Village is $630,000. Likewise, the Alberta Arts Cottage cluster, much smaller, but still kind of an infill project, and that price point, $599,000, still lower than the median house price in Alberta Arts, which is $702,000.
Wow.
And I also just read about some that are like Oswego that are even higher. But again, it's all price of land and so on. So here we're going to be looking at the details of the case study, which is a prototype for energy efficient cottage clusters on a Milwaukee site. The case study team includes Tallwood Design, which is a collaboration between the Colleges of Engineering and Forestry at Oregon State and the Architecture Energy Studies building at U of O. And Tallwood is an interesting collaboration. It's pretty much one of the first in the nations to advance mass timber and other wood product solutions. Others in the team include Homework Development, PAE, and Energy Design. And Vince is here to talk about their work on the project. So the goals of this were to develop net zero housing for net zero workforce housing. Tallwood Design actually received a grant of $24 million from Build Back Better to develop the actual built prototype, which you see in the photo on the left. This is the actual construction of the module in Oregon State's Wood Products Lab. And the kind of goal was to develop it, study it, test it, and then refine it as a replicable model for net zero affordable housing. So here we have more developed site plan of the 36th Avenue site. Note that north is to the right. So here we can see clusters of the Milwaukee Courtyard cottages. Note that some of them are duplexes and some are kind of attached. Well, they're detached, but perhaps have kind of a narrow walkway between them. But they're all clustered toward a center focus, which is a common space that you see hatched kind of in the middle there. And notice that there's a good sized tree canopy around let's see, that would be the east and west sides that preserve the tree canopy for many aesthetic reasons and site reasons. Some of the trees would need to be removed, but as much as possible, they have been preserved. Note that this is a 3/4 acre site with a density of about 25 units per acre.
Hey, Denise, do you recall this site, what existing stuff was on it? Did they have to demo certain buildings? And then because it's kind of unusual to find a 3/4 acre site that's just kind of empty in the middle of the city.
It really is, yes. And I believe that there is one house that would be demoed or has been demoed.
I see. So really taking advantage of significantly underutilized land, and what a great plan for it.
Yeah, very much so. So this illustration you see here on the left is of the 36th Avenue site. This could house up to 19 units, and the Harvey Street site that we saw in the original site plan just west of this could house 14 units. The units would share infrastructure of water and a solar microgrid system, and each unit is designed as 2-story, 750 square feet. The heating is designed to use thermally conditioned mass in the floor. and possibly cooled with the hydronic floor system in the summer along with passive ventilation.
Interesting.
So the important thing here isn't kind of course, to provide net zero housing for workforce housing, but there's three really key areas here. And one of them is that the mass plywood panels are prefabricated using what they call a digital workflow, which creates an automated system that would cut panels once you input the data. And it would very efficiently produce the panels that are needed for this. You can see that the middle housing concept, the infill cottage cluster would typically make much better use of existing infrastructure. And last, the net zero target combined with the panels merges many goals of sustainability. So here is a list of some of the advantages of the mass applied panels, along with a video showing two of the researchers from U of O. And note that the cottage clusters are described in the context of modular build. So Edward, if you want to show us, yeah, starting at 115.
Sure.
Yeah, right around there.
Right about there. Okay. You guys able to see this?
We don't hear the sound though.
Is the sound coming through?
I don't hear it.
Oh, okay. Here, let me let me look into this. Zoom. Let's see. Audio.
Much less messy site.
No, not yet.
Still no audio coming through?
No, you know when you load that, you have to check the little box.
Okay, here. Share screen and then
video, audio or sound.
advanced screen. Let me look into this. No control, annotate, Zoom, meeting. Okay, here, let me stop sharing and then share. Maybe instead of
Yeah, and usually a box opens up that you have to check. There's a little box you have to check.
I could hear it, but it was just very faint.
Oh,
contents. Okay, let me try. How about this?
Still very faint. I can barely hear the person speaking.
Still really low?
Yeah.
All right, well, we'll just send the link. If you look here, Housing Solutions, the Mass Plywood Home, search it on YouTube and watch it for yourself. And
yeah,
then
great
we'll
video.
we'll jump back into the slideshow. All righty. Denise, you still there?
Yep.
Okay.
Hey,
All right. Sorry, the video is not working. But you, viewers can go search this video themselves and check it out. Anything else you want to say about this slide before we go to the next?
no, the video is just an interview with a number of people, including the two of the researchers at U of O. And they were sort of highlighting the assets of the panels, how they did a factory tour of the Furness products and kind of interface with them to come up with a concept of how to design this and then test a 3-inch thick plywood, the 3-inch thick mass plywood panel on their digital workflow system. So yeah, it's kind of fun to watch.
Okay.
Okay, and here's another one that we don't need the volume for, but it's kind of a fun thing to watch. There's few homes that have been built with these panels, but here's an example of one that is a little bit unique in terms of it's not touted as one that was um, used for necessarily ecological reasons or affordable reasons, but it is a site that is in the Cascades east of Seattle. So very short building season, very snowy, remote site. So if you want to play that one, Edward, it's about 50 seconds. And there we go.
Okay.
Yeah. And it's okay to not have the volume for that one.
Okay.
Right. So they're just showing us the site here. And the panel products that are used to build the A-frame. And there it is going up. Okay, and I do believe, if I remember correctly, this house is available on VRBO as a vacation rental.
Vincent. Okay.
There we go. Okay, so inside some of the panel houses, the photo in the upper left is an actual photo of that A-frame that we just looked at in the video. And the panels again provide very quick construction during a short building season to a site with difficult access. The bottom two images are illustrations of the Milwaukee cottages as they might look if they were built, showing the exposed wood. So these panels can be left unfinished if you like, and we're going to take a look at the next slide has a cross section, which I found very interesting to look at. So on the left, you can see a typical frame wall, and on the right, you see the proposed cross section if these were to actually be built. So you can see they have a plywood clad on the outside, but they have a 3-inch thick panel. And notice that outside the panel, they have continuous exterior insulation. So they have lots of insulation there. Toward the bottom there, if you want to point on the bottom, the system chaseway is designed at the wall base to provide separate enclosed space for mechanicals. And again, the insulation is continuous over the panels, which can greatly diminish thermal bridging typically found in frame construction. Next slide, we'll look at photo of the mock-up that they did of this window system. So they built the in the OSU lab there, they built the prototype, and they also built a separate one, really just kind of focusing on window details. So here you can see the routing, the center slide shows the routing of the panel that was needed to place the window. And they're kind of playing, experimenting with that a bit and finessing it. This window installs about an hour, start to finish, including the routing, and the tolerance on the opening for the window, because it can be cut so accurately, is only 1/16 of an inch, and goes up in about an hour. And the 1/16 of an inch is very tight compared to regular frame construction, which would be maybe a ½ inch on either side, up to an inch, depending on how the builder does it. Okay, so this is the actual mock-up where purpose of building this along with the prototype again was to explore construction details and then to use it to advance the design for replicable housing for future units. So here you see the left is the outside and the right is the inside, and they have let's go to the next slide. We can take a look at, there we go. So a little kind of a close-up top and bottom. You can see the white sliding, they call it an energy shutter. So they've got a typical window. It's code basic window, but they've developed this energy shutter that's sliding on the inside. It's made of a translucent polycarbonate, and it can then provide additional energy improvements for the window area. And you can see right below there, the boxed out area starting for the chaseway. Okay, this is a proposed heating system, a diagram. The proposed heating system is hydronic in the floor, again, heated and cooled water. The diagram shows the concept of a district heating system used in a shared heating loop for the hydronic heat. Thermal storage tanks can also provide cooled water for hydronic cooling in the cooling season. A microgrid PV can provide power for central heat pumps during a power outage, thereby adding additional resilience for the homeowners. And here's a cross-section of the passive, or what you might call ventilating system, natural ventilation. Prevailing summer breezes can be captured to stimulate natural ventilation, both on the first floor with the windows and the doors, and on the second floor with the windows and the skylights. And as noted in the previous slide, the hydronic floor system can switch over to being a chilled water system for additional cooling.
Yeah, so for viewers catching this webinar on YouTube that may not be from Oregon, this cooling method is very climate zone dependent. So the climate zones that benefit the most from this type of cooling system is ones that have, hot afternoons, but quite a big temperature drop in the overnight hours. And so then this concept of night flushing works really well. If you live in a climate zone where it's hot even into the night or it's very humid overnight, then this type of cooling system would not work well. But if you happen to be building in a climate zone where you can take advantage of the daytime versus nighttime differential, the energy savings of doing this type of cooling ventilation system is quite substantial.
Yeah, and also another note, I was researching this a little bit, the prevailing breezes in the Willamette Valley in the summer vary depending on what city you're in too. So that the location of the windows and the placement of the unit has to be tweaked a little bit. This is just a reference here for the energy assumptions that we use. The table shows our assumptions. Note the envelope across the top there. The codes or the assumptions here are basically code minimum. So we've got like the windows are 0.27, the doors, flat ceilings are R49. The walls are called for R20, but note this does not take into or doesn't reflect the benefit of the continuous unbroken insulation that is on the outside of the panels that results in reduction of thermal bridging as compared to stick framing. Next.
And so before we go next, I want to point out that at the time of this study, heat pump water heaters were assumed to have an energy factor of just 2. Nowadays, if you go anywhere and buy a heat pump water heater today, you're going to get a energy factor that's closer to 3.5. So heat pump water heaters have improved their efficiency quite a bit. What is not code minimum is the air sealing assumptions. And so these mass ply panels assume that when you put together, you can quite easily achieve an air leakage rate of 2.5 to 3 air changes per hour when tested at 50 Pascal. Many stick-built construction homes struggle to achieve that level of air tightness. Typically, many stick-built construction homes around 4 or 5 air changes per hour, and so this is a market improvement in air tightness, which results in fewer drafts and greater efficiency and greater comfort. Okay.
And then the last slide I'll just point out here is the assumptions for appliances and electronics. So the power used and the cost per year. And it gives the models that were assumed.
Okay. All right, and now we're gonna dig a deep dive into the solar design, and Vince will present those elements.
So this is a kind of a different concept that most people won't recognize. With a cluster design like this, instead of each building, each unit having its own electrical meter, all the electricity on the site is shared. So there's one electrical meter on site. Everything comes in to one place and then goes to each individual unit. And each unit has its own electrical panel. And there's cost savings just in that. So one of the responses the utility companies have had over the years to making sure their infrastructure is handled is the cost of meters has been continually going up. So that's the cost that you pay whether or not you use power. And that's gone from an average of about $12 a meter residential in a lot of the areas to over $30 a meter currently. And it's a simple way for a utility company to make sure that all of their costs are met. So there's energy or money savings with this strategy. It also allows for a lot that's shaded. Both of these lots were highly shaded, which makes a very livable place. It's nice to have the shade trees in the summer, and there's a little courtyard in the middle of both of these cottage clusters that you can hang out in, your kids can play in. And but obviously some of the houses don't have enough solar potential to be worth putting solar on. So when you buy into this unit, you're buying in to the solar as well as the house you're living in. And the solar is shared between all the different units. So the solar simply feeds back into the main meter, and then you get a discount based on what the whole site achieved as an energy balance for that month, rather than each individual unit. In the design, I used microinverters, which is a technology that some of you may have already heard about. A microinverter is an individual inverter, an inverter being a line conditioner that takes the power from the solar panel, which is a direct current power, and converts it to household power, 240 volts AC, and then feeds that back into the individual panel in each house, and then back to the main meter at the site. The advantage of microinverters in this type of a situation is that you're making each solar panel an individual unit. So each solar panel has its own inverter on it, and when sun shines on that panel, it outputs power back into the system. A lot of our systems use something called a series string inverter, and those work great. They're a little less expensive for the equipment, but they don't work well in a site like this because each series string of solar panels is put together to feed back into a unit, into the inverter unit. And that might be up to 15 or 16 panels to a series string, depending on the voltage of the panel and a bunch of other different criteria of the climate. And if any part of that series string is shaded out, the rest of the series string is impacted, and it reduces the power output quite a bit. So let's say we had 10 panels in a series string and one panel was shaded. It's going to reduce the output of that series string by up to about 60 to 80%. With a microinverter, um, you have just each individual panel outputting individually. So if the panel next to one is shaded, there really isn't any issue with that. The panel that's in the sun is still going to put out power. The drawbacks to microinverters are that you're putting your electronics in the place in the building that has the most thermal cycling. So it gets the hottest and the coldest throughout the day. And that means that through the life of the system, you're going to be replacing some of those microinverters. Electronics degrade based on thermal cycling, typically. The more something thermal cycles, the faster the electronic components wear out. So at some point in that integrated circuit board on that inverter, you're going to get a failure of one of the components, a resistor, a capacitor, or something like that is going to fail. But most of the microinverter companies have good warranties. Most of them are warranted for 25 years, which means that you're going to just be paying the installer to come back out and replace them, but the equipment is covered.
Vince, in your 20 plus years of doing solar, what's the failure rate of these microinverters? Is it extremely low?
It's changed over time. When we first started using microinverters about 15 years ago in my company, we had kind of a higher failure rate. There was something called a catalytic capacitor in the units that tended to not do well with that high thermal cycling that was happening for the units that were out in the field. They were getting really hot, and we had quite a failure rate. Since that time, they've made them a little more robust, and we're not experiencing a high failure rate on the ones that we've installed in the last 5 years. But we'll really only know in the next 20 years whether or not there's a failure rate for those units. And my guess is we'll have failure rates on those units just because they're electronics and they're in a place that has high thermal cycling.
Yeah.
Um,
I really appreciate you speaking on the topic of the impact of shade on solar panels and how different solar panel setups are impacted by shade. Because, like, I don't think uh, every single solar contractor, trying to r race to give the lowest bid, really reflects this uh, aspect to customers in their quotes. And some customers who don't understand this might end up picking a quote that is lower in cost, but the actual energy output due to shading conditions is significantly less. But of course, if you're a different customer with very little shade on your property, you can actually reap the lower cost systems of a string type panel inverter setup. But it really is very site dependent and what situations you're dealing with.
yeah, that's exactly correct. With a house that has full, what we call sun window, so it's completely open to the sun on hopefully a south or west side for our climate. Series string inverter is actually preferable. The inverter is going to go in your garage or maybe on the north wall or east wall of a house, so it doesn't really have the problem of high thermal cycling. So it's better for the electronics, and it's going to last longer, more than likely. And the series string inverters can be quite efficient, and they're less cost as well as a microinverter. So there's advantages to using series string inverters. And if you're using a battery system, if you're adding a battery system to your building for energy resilience, so that when the grid goes down, you still have power, most of those inverters are series string inverters. There is one, In-Phase makes a battery system that runs on the power output from their microinverters. But there's some disadvantages to that. You get a little bit more loss when you AC couple. So if you have an inverter outputting AC power, a microinverter in this case, and it goes back to a direct current battery, which all batteries are direct current, then you're going to lose a little bit of power because you're changing the type of power and the voltage of the power. And every time you do that, you lose a little bit of power. So the best, in my opinion, the best way to have a battery-based system is with a DC coupled system. So you're going from high voltage DC to a high voltage DC battery, and there's a lot less loss. So you get a better round trip efficiency from solar power feeding into the building to actually being able to use power out of the battery in your home.
Excellent. And then in a site with lots of tree coverage, um, is that do you have to there it may be that in these types of sites you worry about power outage a little bit more because you might even in a cottage cluster you probably route all the wiring between all the different homes underground, but then right outside of your cottage cluster you're probably going to go back onto above ground, on a utility pole type power distribution because it's the most common and lowest cost way to distribute power into neighborhoods. And in heavily forested or tree covered neighborhoods, the chance is higher for those trees to touch a power line and trip a circuit breaker in the distribution feeder. So
That, go
having
ahead.
battery backup might be a good idea if you live in that kind of neighborhood.
Definitely. We're seeing more and more power outages. The utility companies really have their work cut out for them with climate change. We're getting a lot more bizarre storms, ice storms. We had a pretty severe ice storm in the Eugene area about 4 years ago that took out power for some of my clients for 2 to 3 weeks. And people that had battery-based systems fared a lot better. We even recommend having a battery system and a small backup generator that becomes a battery charger. It's a better way of using an engine generator rather than leaving a generator running 24/7 to power a refrigerator or a few lights. You might have a 5 to 10,000 watt generator powering 2 to 300 watts of load. With a battery system, you can use that generator to recharge the battery and then run those small loads from the battery and inverter system rather than directly from the generator. And that allows you to, on day 4 or 5, if the power's still not back on, to crank up your generator, recharge the batteries. That's, of course, if the solar hasn't recharged them.
Hmm.
But it's good, kind of a double backup. And really, the only advantage of a battery system is backup in our climate. There can be advantages to financial advantages to battery systems in areas where you have very divergent costs for something called time of use metering, which is something you can opt into with some utility companies. And that works really well in places like Arizona or California, where their rates are very different between on-peak to off-peak. So if you can store power in your battery and then feed it back in during peak time, you get credited at a higher rate. Like some of the rates in California are 14 cents a kilowatt hour off peak and 42 cents a kilowatt hour on peak. So you can see that economic advantage there of storing the power and then feeding it back into the utility during the on peak times. So far, Oregon really doesn't have much difference in the values between on peak and off peak. There's definitely some utilities have it, but the time of day doesn't work out as well for solar and battery. It's better to have that. Like California's on-peak time is from 12 noon to about 6 p.m., which is also a time that solar puts out a lot of power. So you don't have to rely just on what's stored in your battery. You can also use the solar to feed back in during that time. Batteries do add a lot of cost to the system. Costs have come down quite a bit in the last 5 years.
Well, it's come down a huge amount.
Yeah, with lithium-ion technologies. And I would recommend putting in lithium technology called lithium ferrous phosphate, or lithium iron phosphates, it's sometimes called. That's the most stable lithium technology currently. The least possibility of it causing a fire if you had some issue with it. Um, lithium nickel cobalt has been used in home systems as well. I think of that more as a technology that works better in cars because it has a higher energy density per weight than lithium ferrous phosphate does, but it's more volatile, more likely to cause a fire.
Hmm. Yeah, even cars are now moving to LFP batteries or the iron phosphate variety, just purely because of cost being a major driver.
Yeah, they have a higher cycle life too. They
Right.
tend to uh, a cycle being one full charge to discharge. They tend to have much higher cycle life than lithium nickel cobalt does.
All right. Well, we should keep moving through some of these slides, just
Next
and
slide.
make time for some Q&A.
Yeah, as we mentioned already, trees are great. We want trees on our site, but trees and solar don't work well. And as was mentioned earlier, you really don't want to put solar in the shade. It's not going to do anything for you. And in driving around, I see that fairly commonly. Either the company doing the work didn't understand how it was impacting the solar output of the system. I've also seen solar in the wrong orientation, where it's faced either north, which of course is not going to put out much power, or east, which in our climate, it still works on the east exposure. It's not as good because in the east exposure, we live in a very humid climate in a lot of ways. And up at about 3,000 to 4,000 feet of elevation, there's a lot of liquid water molecules in the environment up until about noon or 11 o'clock to noon, even in the summertime. And a liquefied water molecule has a lot more impact on the incoming solar radiance. So if the sun's coming down and it's striking a water molecule, it has a prismatic effect on the light. And it hits that water molecule, the liquefied water molecule, and it spreads the light out, decreasing the actual power that you're getting out of the sunlight. Whereas after 11 o'clock or noon, so that's a south to southwest to west orientation for your solar array, it puts out a lot more power. So a good design really takes into account that your roof gets full sun, it's not shaded. If it is shaded, we're going to use microinverters or DC to DC optimizers so that it's not going to impact the whole series string. If you think about it, let's say there's a tree up to your southwest that shades your roof. That's going to be a moving shade that goes across your roof as the sun progresses through the day. And so a microinverter or an optimizer approach is much better. And of course, we all want trees. I don't recommend that people take trees down on a property. The tree is going to provide both ambiance and it's also going to provide summer cooling, like it mentions in the slide. And that, if you're using an air conditioner or something like that, or just the comfort from the tree providing that shade for your house, especially in the south or the southwest for a home, really is a good thing. So we work around trees and make a solar system work, or there is the uncomfortable situation when someone calls me up and they're really excited about solar, and I take a look at their home and I'm like, no, I'm sorry, but your site is not situated well for solar. And a lot of people will be like, well, I see the sun up there, during the summertime. And as an installer, we use these tools where we can tell from satellite imagery and from something called LiDAR data that, how tall the tree is next to your house, how much shade it puts on your roof. And so we can tell rather rapidly, without even coming out to your home, that you don't have a good percentage of sunlight on your roof over the year. Let's move on to the next slide. So it's a little bit off the screen somehow. in my view.
Here, let me see if we can fix that.
That's better. Thank you.
Oh,
That's better.
there.
So you can see the green circles are the trees on site. And so some of those cottage clusters were completely shaded. But with this type of an approach, because we're feeding all the power from all of the different roofs back in to one central point, it didn't matter so much. So we put solar where it was had the highest power output and kept it off the roofs that didn't. Let's go to the next slide.
Okay.
So there's the solar design for one of the Milwaukee Courtyard projects from my design view. So if you look at the little green bubbles that you see there, that's me drawing in the tree that's existing. And that lets the system know how much shade and sun there is on each of these roofs. If you're looking at the color of the roof, the darker color represents a lower irradiance per year, lower kilowatt hours per year of sunlight on the roof. And the lighter colors have a better sunlight. So we put the solar arrays on the roof based on the actual irradiance of that section of the roof. Let's move on to the next slide. Here's the top view of the same thing, looking at the irradiance on each roof and where we were able to place solar panels that really actually worked. We kind of already went over some of the benefits of microgrids, and let's see, we'll kind of read through this really quick. I'll let people just read through that on their own. We've kind of covered most of that already.
Okay.
Okay, so sizing and cost is obviously a big thing with solar design. We're always trying to keep the cost down as low as we can. And there's a balance point for that. Obviously, we could use really inexpensive solar modules. There's a wide range of costs depending on the solar panels, where they're built, how well they're built, what they are. We can use a really inexpensive panel, but more than likely the warranty is not going to be as good on that panel. And often the power output isn't as good. So you're trying to find the balance point where you've got a really quality panel with a good warranty and a high energy density, so you can put more power in the same footprint. That's been getting better and better since I have been involved. The first solar panels I installed back in 1982, they were made by Arco Solar, and they had a 30-watt output. And about a 6% efficiency.
Yeah, and they cost an arm and a leg.
Yeah, they were actually a hand soldered unit. Each of the cells was soldered in by hand into these units, and they were encapsulated by hand. And they were quite expensive. The first units I bought were about $12 a watt, just for the solar panel. And now a fairly common cost for a residential system is about $3.50 a watt, $4 a watt.
That's installed.
Including installation permits, everything done. And this solar panel, though, was great because people could use it for off-grid use. And so they wouldn't have to run an engine generator all the time for power. And so my first clients were all off-grid. For about the first 10 years of my involvement in the solar industry. Then the grid tie came around, and that allowed us to feed power back into the grid from a site. And now we're doing a combination of that we call a hybrid system or a multimodal system. And that's the grid tie coupled with a battery that's for backup or feeding back in for time of use, and a high efficient inverter.
Hmm. So these numbers here, these are from a few years ago, correct, Vince?
They're from a few years ago, and they've come down quite a bit. Solar panel costs have come down quite a bit.
Right, but
Labor's gone up,
even so, a few years ago, like, we're seeing this economy of scale here between if you look at the rows that are 15 unit cost per unit cost versus 21 unit cost if you do the division. And then also like these costs are, compared to doing a single family house today still is quite low. So on a per unit home. So I mean it seems to be that this is a great example of how if you're going to do 15 or 21 units at the same time, you do get some economies of scale with doing solar.
yeah, there's a huge advantage to doing a cottage cluster like this. Um, every time we roll a truck out of our warehouse, it costs us money. We've got to load the truck. We've got to wait for everybody to show up and get there and get ready and get everything in the truck and roll out. So when we're rolling out to the same site over and over again, it becomes more efficient. The crew is more up on what needs to happen. So there's a labor efficiency that happens in a system like this where we've got a larger job. The same thing happens on commercial jobs. If we're doing a commercial job, okay, day 2 or 3, yeah, we got some panels up on the roof or we got the inverters up on the wall. But day 15, 16, 17, the crew really knows what they're doing. They show up on site, they've got everything figured out, they got all the parts they need. The work gets done faster. So there's an economy of scale with labor. There's also an economy of scale with the equipment. If we're buying a larger amount of equipment, we get a better price on it. So if we're buying for just one home, we're going to order that equipment for that one home and we're going to get a certain price. If we order it for a bunch of homes at the same time, kind of like what Solar Oregon's doing with their
Solarized campaign.
solarized projects,
Yeah.
we get a better price on the equipment, and often those, it's all in one place, so it makes it simpler to get all the equipment that we need to the site and get it put up. Let's go
So,
ahead and move on.
Vince and Denise, are these pricing for time of day rates? Are they for Portland General Electric or Pacific Gas and Electric down in California?
This is probably it says PGE, so Portland General Electric.
Okay.
Although I haven't personally seen these. This came out of a study that was done for the Milwaukee courtyard cottages.
No, these are from Portland General Electric.
Yeah.
Are these current?
Yep, yep.
Okay, so Vince, you were saying that down in California they have really big price differences, which would justify perhaps just even buying a battery just to be able to take advantage of charging the battery like in the off-peak hours and then basically using the electricity from your batteries during on-peak hours and then basically saving cost on your utility bill through that process. And you mentioned how it's important to have a big price difference between the off-peak price and the on-peak price to justify buying that battery. But, here, if these are current pricing, 9 and 43, that's a pretty big price difference. So it may be that it's worth it.
I stand corrected. Yeah. It could very well be worth it to help pay for a battery system.
Yeah.
That's going to be on an individual basis for each site, but we could look at the site and see how that's going to pan out. Part of it's going to depend on when the homeowner or building owner uses power too.
Sure. Yeah, that makes a big difference. Yeah, well, we'll consider doing a green energy series where we dive deep into current day time of day rates across Oregon and the current, much lower cost batteries to see where in Oregon it may pan out or not pan out to do this sort of battery energy transfer within the home. So
Mhm.
maybe stay tuned for at beginning of next year for a webinar on that. And so, yeah, speaking of upcoming webinars, we have another Green Energy Series webinar on December 6th. It's the first Saturday in December at 10 a.m. again. And that topic is on deep diving into energy rates. We're going to get a guest speaker who is an expert on energy rates to kind of help us deep dive onto that topic. And then Solar Oregon has also a annual meeting where we have guest speakers talk about kind of the current state of solar, highlights of the year, things to look forward to, in the current whatever climate of the world. Sometimes people might think, oh, well, the future is not looking that great. Well, solar, despite all the bumps in the road, it's still actually looking pretty good. I keep saying that the price of batteries, for example, has gone down by an incredible amount. Even with tariffs, solar panel pricing has not really significantly increased, and companies are moving factories and developing new factories in within the U.S. to be able to take advantage of local production that is not subject to so much tariffs. So we'll have speakers at the annual meeting in December 11th speak about maybe that and other wonderful topics. And so if you want to register for the annual meeting and attend that, yeah, feel free to do that. All these events can be found Solar Oregon, and then if you search Solar Oregon Eventbrite, you'll get to our Solar Oregon Eventbrite page, and you'll be able to see these upcoming events and sign up for them. Really great opportunities there if you're in our area. And then, of course, all the uh, webinars are recorded, and so you can find past webinars on the Solar Oregon YouTube page. And if you like all the work we do, feel free to visit the Solar Oregon website and become a member or to donate some money to our cause. You can also, if you have a smartphone, scan this QR code, um, however you want to access. And with that, we all thank you all for attending this webinar and look forward to seeing you on another webinar. And if you have any questions that didn't get answered in the live Q&A that's going to happen shortly, you can contact us at info@solaroregon.org. And with that, I will go look at the questions to see what questions we have. Okay. We have a question about cottage clusters as opposed to which detached units as opposed to like row housing or townhomes where they have shared walls. Wouldn't that greatly increase efficiency because you have less exterior exposed walls and then also potentially save costs with not having to apply exterior siding to so many surfaces? Denise, do you have any comments on that?
Yeah, that's an excellent point. And all the cost savings and the energy savings are spot on. And the idea of cottage clusters is simply, I think, for people to have a sense of having their own home, even if it's smaller in 2 stories. It has some level of desirability that townhomes don't.
I see. So it's a cultural dynamics and perception by the buyer that's driving that decision to have detached walls versus attached walls.
I would say, yeah, that is the case. Yeah. And then the other thing is townhouses, there's, when you do cottage clusters, there's no zoning law that says you have to have open space, but the ideal version, and it's been set with some examples, is that there is a shared space in the middle, but everyone can retreat to their own separate place with their own separate walls.
I see. And of course, if for people who are concerned about noise transfer, even though these attached townhomes do have code requirements for, uh, thick levels of drywall between the units, there's still this perception and fear that, if you have a loud neighbor, you can hear them through the wall. And so cottage clusters that are built with detached homes might be better to manage that potential fear of a noisy neighbor. Um, Realistically, with how, if you're a good builder and you design, walls are, exceeding the code minimum for sound transfer and also fire code, um, the chance that you're going to hear your neighbor through a attached townhome wall is very small. Um, so I think it's the cultural perception needs to catch up with the technology and the quality of construction that even code minimum requires nowadays. Okay, let's give people a few minutes to see if they have additional questions. I'm not seeing any right now, but let's give people another like 30 seconds. Oh, there is another question. Best practices for parking for cottage clusters. I did not see much in terms of parking in those drawings. Do you, Denise, do you need me to go back to the slides to highlight parking, or was there
Uh,
really none?
there's, there's the one slide for the site plan for the 36th Avenue site, and it does show a few pockets of parking, but it's not anything like one per unit. So that is an issue, and I think that is a concern that, folks can have if they're in a neighborhood where a cottage cluster is in the makings. If somebody has kind of an oversized lot and a smaller house, and, it's kind of fair game or right for the taking to do some cottage clusters, then parking can be an issue. In cottage clusters, you see, the two examples I had in Portland, one of them had quite a few units, but the other one only had three. So with the three units, I did some research, but I couldn't find, without going over there, I couldn't find an exact layout of the parking. But I do agree that the parking, at least in this case on 36, they had some off-site, or excuse me, off-street, and then some on-street. The other thing to think about with this is they tend to locate them near, in the existing neighborhoods that have established transit, whether it be the bus system or the MAX system. And they also, uh, based on the size, 750 square feet per cottage, maybe one or two people, probably not going to have, maybe you'd have two cars, maybe you just have one vehicle per household.
Right. And so I think when it comes to parking, another kind of thing to think about is what's going to be the future of vehicles and like with whether regardless of what you think about self-driving now, I think the technology is going to get there where self-driving cars are going to get safe enough and reliable enough that we the current fears of the AI self-driving car doing something wrong may become less and less of an issue. But it could be that in the future, like instead of owning a car, you have a car subscription on your phone and you summon the car that you want that day, or it shows up on a schedule if you have a very routine schedule, and it drives up to your curb and you hop in and then you tell it where you want to go. In that case, then like the concept of having parking becomes less and less an issue because you don't necessarily need the car to be right in your driveway and the curbside parking. That could significantly, change, this fear of too many cars in the neighborhood or not enough parking on street parking if we densify neighborhoods. And I think that future might be coming much faster than some people think. So um, it I think I encourage people to be open-minded about that aspect, like know, not having driveways and garages. It might be okay. Other questions? I'm not seeing any. We do now have another question. Okay. In single family detached homes with insulated attics, that's super hot in the summer. Heat pump is in the basement and really cannot cool upper floors in the summer. Any new trusted competitors to Radiant Comfort? Other Gradient Comfort hybrid AC or other heat elimination solutions to cool midsummer. Attic is finished, so roof fan is not suitable. Um, I think this question, like, you're gonna have to message me on LinkedIn and give me some more photos of how your house is set up because seems like you're trying to take some of the cold air from the basement and be able to transfer it up to your upper floor. But how to actually do that, you're gonna have to give me a sketch of like a cross section of your house, and then we can figure it out. Okay, well, we're a few minutes past the hour, so I'll give everybody time to enjoy the rest of your weekend. So we're going to close this webinar, and if you missed it or the beginning of it, then feel free to check out the YouTube video that'll get posted in a few days. With that, we're going to close out, and thank you all for attending.